Hello all, welcome to another session in AWS. So currently we are into seeing the service which is EC2. So first, every time we log into our dashboard, we should remember to select the location or the data center where our VM has to get hosted. The virtual server has to get hosted, which is our instances. So in our previous sessions, we discussed about what an instance is. We even launched an instance. Added to that, we hosted a web page to the instance. So how did we do that? We configured the IIS. We saw about the port numbers of our hypertext transfer protocol, HTTPS, and we even discussed about RDP and all such. Now in today's session, we're going to be discussing about EBS volumes. So let's just understand what an EBS volume is. So in layman's perspective, as an end user's perspective, let's just first understand what an volume is. Fine. We all have our laptops. It might be a laptop, it might be a desktop, it might be a workstation. We all keep working on it. So every time we boot the OS is stored somewhere and it is taken to us or taken to the view in the desktop from a particular storage location, right? So what's that storage? So we have a hard disk drive or it might be a solid state drive. So we have a place which is going to be storing all the data inside our device, and hence AWS even has a volume or a storage space which is dedicatedly given every time there is an instance that is launched. Obviously, instance is going to be having the OS in it. We saw that in our AMI where we had various images of Linux, Red Hat, and Windows, and so on. So the OS as well as the file that requires to run your OS all gets booted, and we need a storage space in AWS to store these data. And that's the need to go for elastic block storage. So they are providing the service through elastic block storage, which means you can modify your storage as and when you need, which means you can scale up the storage as and when we require. So let's quickly go launch an instance, attach a volume to it, and just see how it gets reflected in our server. So I'm gonna go with launch instance. I'm gonna give the name of my instance, let's say EBS demo. Again, we're gonna be performing the same set of procedures when launching. So go ahead with Windows. Choose the AMI, which is the Microsoft Windows Server 2022. So that's under our free tier eligibility criteria. Just wait for the instance type to change from T3 micro to T2 micro. Yes. Create a key pair. Create a key pair. Now here in network settings, I can go ahead with selecting the subnet. So every instance that is launched is going to be having its set of network configurations, which means there is a public IP assigned to the instance. And it runs in a private cloud, which we call as virtual private cloud. So we'll discuss about all those in our upcoming sessions. As of now, just understand VPC is a entire network, the entire internet in the AWS cloud service, which is further logically divided into various availability zones. So, United States, Ohio is going to be having its own data centers hosted on all these availability zones. So, Ohio is going to be having, say, three availability zones. Similarly, the other data centers or the regions is going to be having some set of availability zones associated with it. So we can go ahead with choosing the availability zone of our choice. I am just going to go ahead with 2A. So how do we identify it? You can see here the availability zone here is US East 2A, and we have 2C, and we have 2B. So I'm just gonna select 2A, which means my instance is going to get placed in this particular availability zone. So the IP address of the instance is public, and hence I have to enable public. If I don't want my instance to be public, if I don't want any other community or the team to view my instance, I can go ahead with disabling it. Let's just go ahead with enabling it. So here, we're supposed to configure the firewall, which means it's already given to us. All we have to do is just create a group name for the security. So I already have existing security groups which has already been created. So I'm gonna go ahead with it. If you don't have a security group, you can go ahead with the first option to create a security group. So I'm just gonna go ahead with Launch Wizard 29, which is a security group which I had already configured. Now, this is where your EBS comes into the play. So the volume which is going to be having your OS is your root volume. And the volume which is going to be having the supporting files like your applications, logs, information about your databases and all those stuffs which are supporting files for your OS. Those will always be stored in your non-root volume. So your root volume is the one which gets booted first every time you are initiating your instance. Every time you're choosing your AMI, which is your operating system, and by default they are providing us 30 GB. So just go ahead with whatever the features that's been given, and let's go ahead with launch the instance. You can see here the free tier eligible customers can get up to 30 GB of EBS, which is your elastic block storage volume. And the hard disk drive that's going to be given to us is the solid state drive, or it could be a magnetic store, which could also be chosen by you. We can see various options, flavors of disks, right? Storage disk. So general purpose, which is SSD, and which is under GP3, and we have general purpose SSD, which is classified under GP2, provisioned IOPS SSD, which is IO1, and provisioned IOPS SSD, which is IO2. Fine. Let's talk about few metrics here before moving into launching an instance. So the performance of Amazon service is totally dependent on how efficient they were able to utilize the resources. So when we talk about resources, your volume plays an important role. The block storage plays an important role because every time the user is launching an instance and trying to work on the instance, perform some read and write operations to and from the instance, there are some traffic or some amount of data that is transferred between EC2 and the EBS volume, right? That's how it happens in our laptop even. So every time you boot the operating system and you work on some certain type of applications, the request goes all the way to the hard disk drive. And from there it goes to your RAM, and from there it comes to your processor. So the performance of a system is totally dependent on the type of hardware that you use. So we can go ahead with the hardware selection. And this is going to be playing a major role in deciding the metrics of your AWS service. What's that metrics? We have something called throughput, we have something called IOPS, which is further classified as bandwidth and capacity. So, bandwidth is the amount of data that could be sent within a given network space to and from your EC2 and EBS. So your bandwidth is going to be decided based on the throughput and IOPS. What's throughput? So in a given point of time, at a given point of time, you are able to perform read and write operation as efficient or faster as possible. The amount of bits you can send within a given point of time, how faster it happens, your read write operations. So we have something called IOPS. What's IOPS? Input and output operation gets executed in your AWS always. So when you're deploying an application, when you're running your modules, there's always input and output operations that keeps running inside the system. There might be some specific applications which requires high input and output, which means how faster the input and output operations gets executed within your AWS service. So based on these criteria and metrics, you can go ahead with choosing whichever type of disk you want to. If you just want to go ahead with storage purpose, then just go ahead with the disk which is provisioning only the storage service. If you would want to go ahead with applications which requires a high IOPS service, then go ahead with the IO1 operation. So apart from this, we have something called cold HDD and throughput optimized HDD and magnetic, which is a standard one, classic one. So these two are specifically used for storing data and not for IO operation. So which means the capacity. So we just discussed about bandwidth and capacity. So the capacity is also provisioned as a service through cold HDD, throughput optimized HDD. And we even have the general purpose SSD and general purpose SSD GP2. Fine. So that's about a detailed classification of how the storage works. Now, for our instance, which is going to get launched, we are going ahead with the default GB that's given, which is in the root volume. I'm just going to go ahead with GP2 and say launch instance. Go to view all instances. Refresh the page. You can see here the instance is created and the status of the instance is running, but it is still in the initialization phase. It has to move from initialization phase to 2 by 2 pass check, which we saw in the previous session. So let's just wait for it. So this totally depends on the network, which is how speed your internet is, and might be due to climatic conditions, or there might be a delay in initializing your instance and your storage respectively. So we have to remember every time there is an instance launched, it is from the root volume, and any additional storage that we are going to attach to the existing is going to be a non-root volume. So we're going to be seeing few actions that we can perform on this specific volume that is hosted for us, which is dedicatedly given to us. So we're gonna be first modifying the volume because we have an existing volume of 30 GB. We can modify it. Say a real-time scenario where an application which is running on an EC2 instance is requiring an excess storage space of 40 GB or 45 GB. But the basic volume that is given to us 30 GB. We can scale it up. We can modify it. But the minimum criteria is 30. We cannot scale down the volume. So say we would want to store files which shouldn't get associated with the root volume. So we even have an option for that where you can create a new volume exclusively and attach it to your root volume as and when required. So first we're going to be performing modify. So once the modify operation is done, we're going to attach that to the existing volume. And then we're going to see that in the server, whether it's reflected in the server. And then we're going to attach a new volume by creating a new volume and see how it is getting reflected in the server. Yes. Now let me go to volume. Just scroll down to the left panel. You have the Elastic Block Store service. We have an option here which is volumes. Click on the volumes. This is going to reflecting as the store, the volume store, which means the hard disk drive storage, which is of type GP2, which we just selected. And there is a volume ID given to your EC2 instance. You can even name it if you want. The size is 30 GB. IOPS is 100. Fine. As of now, it is in the availability zone 2A, which we selected while launching the instance. Now, let's just launch the instance and see, connect to the instance and see whether it's reflected in our RDP. So go to RDP, download the remote desktop, get the password, upload the private key, decrypt the password, copy the password, go to downloads, open the file, connect to the RDP, paste the password, go ahead with OK. Perform yes. Now the instance is connected. Perform Windows E. Go to this PC. Yes, the volume is provisioned to us. Keep this aside. Minimize the instance. Now go to your EC2 dashboard. Come all the way to your Elastic Block Store. Come to your volume. I just told you, in case if there are some unpredictable situations where you want to scale up your volume, what do you have to do? Select the volume, Go to Actions, go ahead with Modify Volume, click on that. We have the volume ID given here, and we have the type of the volume which you have already chosen while launching it. You even can change it. I'm just going to go ahead with GP2. So the existing size of your volume is 30. Let's say 32. IOPS cannot be changed because your GP2 has some restrictions on IOPS. If you want to change your IOPS to a higher end, then go ahead with IO1, but the maximum is 3000 IOPS. So I'm just going to go ahead with GP2. Modify, click Modify, select the volume, refresh the page. Yes, the size is scaled up to 32 GB now. Now let's quickly go to the server and check if it's been updated. This PC, no, it's not updated here. So what should we do? We have to configure and we have to tell this particular server that there is a disk which is allocated to you. You're supposed to include it with you. How do we do it? Go to your search bar, give the command diskmgmt.msc. Click on the command. You can see the disk which is allocated. We have extended the disk to 32 GB, but still it has to be attached to it. So right click, go ahead with extend volume, click next, next, finish. Go to this PC, refresh the page. Yes, the existing volume is extended from which was previously 29 point something to 32 GB, which is 31.9 GB. Now we've modified the disk. We've extended the volume to the existing disk or the existing volume. Now let's just explore how to attach a exclusive volume to this particular disk. Quickly go to your console, go to Actions, deselect it, go to Actions, go to Create Volume. Now we can select the type of the SSD we would want to. So, and the size even can be provisioned here. So we are going to give the size as 4 GB, say, and go ahead with choosing the availability zone. So the availability zone is obviously 2A, and I want this particular disk to attach to the existing disk which is in 2A. So let me just go ahead with 2A and go ahead with create volume. Select the volume, refresh it. Now the status of your volume is going to be available, which means it is available to perform any operations like attaching it to your existing disk, storing data further. So now click this particular volume, go to actions, go to attach volume. So the volume ID is given, the availability zone is already given. All we have to choose the instance to which this particular volume has to get attached to. So this is an exclusive volume. So here we are about to attach it to the existing instance which already has its root volume, which was initially 30 GB. Later on we modified it to 32 GB, which we just saw in the RDP desktop. So the instance which is running is EBS underscore demo. That's the name of our instance. Go ahead with that. The device name has to be xvdb. Attach the volume. Excuse me. Select the volume, refresh the page. Go ahead and quickly check the status of your volume. Now it is in use. Now we've attached the volume to the existing root volume. Let's go and check it in the server whether it's reflected. Explorer E. No, we don't have it. So what do we have to do? Again, go to disk management. Disk management.msc is the command that we have to give. Click on the command. Yes, we can see the disk which we just attached, which is of 4 GB. Right click on that, make it online. Now it has not been initialized yet. So what we have to do, go ahead with initializing the disk. Okay, now it is initialized. Now go to the unallocated space, create a new simple volume. Go ahead with next, 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 finish. Boom. The volume is here now, which is the 4 GB which we just attached. So you can store your data here. You create a folder for log, create a folder for say test suite. So these are additional data which we require for running an application, not just limited to this, but any type of real-time application could be having its set of exclusive volume that could be attached to the root volume. So this is a non-root volume and this is the root volume, which means when I stop my VM and when I resume my VM, restart my VM, this volume is gonna stay there forever. It is a non-volatile type of volume. But the volume which we just attached as an exclusive volume to your existing root volume, it's gonna be a volatile type of volume, which means whatever data that I store here is gonna go off, it's gonna evaporate once I stop and restart my VM. So let's just go quickly. Okay, detach the volume and see if it is reflected or not. So the volume which we just attached is here. We have the volume ID and the size, which is 4 GB. Go select the volume, go to actions. First detach the volume. Now it is just detached from the instance, which means it is not yet deleted. We are supposed to perform the delete operation now on this. So select the volume, go ahead with action. Let me just refresh the page. Now you can see the volume will again be in the available state. You can either detach, you can either attach, You can delete the volume. You can use it later whenever we want it. Select the volume, go to actions, go ahead with delete volume. So type delete to confirm the deletion, perform delete. Let's see if it's reflected here. Yes. So we deleted the 4 GB volume, but we have the root volume which is already modified from 30 GB to 32 GB. So we can even delete that. But if you terminate the instance, it is obviously going to get reflected in your volume, which means go to your instance. So here you can see the instance which is running. So I'm going to terminate this. So instance state is now shutting down. Let's wait for it to go to terminate. Yes, now there's a warning that's given to us telling that the remote desktop service has ended, which means I have terminated the instance. Now let's just go to the volume, go to the same left panel. So under your elastic block store, go to volumes. We still have the volume in the AWS service, which means every time you create an EC2 instance, you either run the instance, you either stop the instance, you either restart it, or you will going ahead with terminating the instance. But still the volume exists. It's because there is a feature in the EC2 instance. Go to instance. Let's talk about that feature. Go to launch instance. Keep the name of the instance. Go ahead with Windows. So which is 2022 base. Select the Windows. Now go ahead with creating a key pair. Create key pair. I'm not going to launch the instance, but let's just follow the procedure. So let's just keep the network settings as it is. So let's go to advanced in the configure storage. You can see the detailed information about your storage. Everything is coming from here, whatever we have done. So the storage type is elastic block storage. The device name is in the path DEVSDA1. So this snapshot plays an important role. We'll discuss about it in the upcoming session. So the existing size given to our volume is 30. So it's of volume type GP2 and the IOPS is 100 of the minimum limit and 3000 as the maximum limit. So this is that specific operation or the feature which is making your volume to stay even after your EC2 instance is deleted. So this has to be either enabled or disabled. So when you enable it, which is going to make sure that your EC2 instance, every time it's terminated, your volume is also terminated. But on the other hand, if you want it to stay still, then you have to go ahead with disabling it and then go ahead with launching the instance, which means every time your EC2 instance is created, the storage that is dedicatedly provisioned to your EC2 OS or whatever the application that you're running will be there even after your EC2 instance is terminated. So that's about the EBS volumes and the features and its behavior. So I'm not gonna launch the instance. Let me quickly go to the volume again, all the way to the Elastic Block Store, volumes. So the volume is still here. Let me quickly delete the volume. So detaching the volume. It has already been detached because I had already deleted my EC2 instance. So I wouldn't be able to detach or delete or perform any operation on this volume. So basically, your EC2, every time it is initiated, there is a volume by default given to it, which is the root volume. If you would want to modify it, go ahead with the actions of modifying the volume. You can delete the volume, you can attach a new volume to it, detach the volume, and again perform deletion on the volume. So that's how the storage provisioning is done to the end users or the organization or enterprises through the AWS service. So that's about our today's session. So let's meet in the next session with a new topic. See you all then. Bye bye.